So, good evening, dear students. Today we are going to discuss the some of the important question which you may found in your coming IOCL exam. So today we are just start our first chapter, that is theory of computation, and this subject is very simple, as you already bit aware about the subject. Like TOC having the main fourth chapter, that is the finite automata, push down automata, Turing machine, and undecidability. And out of that, most of the time you will get the question from finite automata and push down automata only. Fine. So let's start and discuss some of the basic problems of finite automata, as these are the some standard questions which we are going to discuss today. Okay. So here you can see the first problem. What is the minimum number of states? Most of the time you will find this type of question, finding the minimum number of states in DFA over that accept over 0, 1 over 0, 1 that accept all binary string having an even number of ones. So if I talk about only, let's see one by one the concept. Suppose that my sigma is only 0. Fine. And if I want even number of 0, then what is the DFA? Even number of 0 means suppose that we have the simple string that is called epsilon. Fine. If we have the epsilon, in epsilon we have 0 number of string and 0 number of 1. So it gives me odd number of ones now. And if I want always all the even number, so here okay, if I want to go with only 0, then this is the case. So I required 1 and 2 state. That is the case when my sigma can consist with only 0. And suppose my sigma is 0, 1. Then in that case, total number of states are again 2, but the DFA little bit different. I want even number of ones, and if I want even number of ones, then this is the case. But what about any number of 0? Yes. So again, always in case of even number of ones, we require 2 state. This is the DFA with only sigma as 0, and this is the DFA with only sigma as 0 and 1. What is the minimum number of states required in DFA over sigma? Again, here also 0, 1. Here sigma is 0, 1. That accept all string whose number of ones is divisible by 3. So you want number of 1 has to be divisible by 3. Fine. So if I want number of ones divisible by 3, it means I want all those strings in which the number of ones is multiple of 3. It means either 0 ones, I don't want single one, I don't want double one, but yes, ultimately I want 3 1 or multiple of 3. And in that case, any number of 0, any number of 0, and any number of 0. So that is first state, second state, and third state. Because there is no such restrictions on the number of 0. Number of 0 may be anything, but number of ones always be divisible by 3. That means 0, 3, 6, 8, 9. All the strings having these many number of ones. Fine. See, the state 1 represent 0, 0, 3, 6, 9, 12 number of ones. It accept all string having 0, 3, 6, 9, 12, or that is multiple of 3 ones. Not, and it does not bother about the number of ones. If I talk about the state 2, suppose in your system, in this model, the state 2 is your final state, not the state 1. In that case, it accept all those strings having the number of ones is, when I divide the number of ones by 3, then it gives me 1 as a remainder. Whereas if I make the final state as state number 3, in that case, all those strings in which number of zeros are any, but number of ones, when I divide by 3, it always gives me the remainder as 2. That means 2, 5, 8, 8 number of ones, 5 number of ones, 2 number of one, all those strings. Right. Let's please kindly construct the DFA and tell me what are the total number of state in this case. What is the total number of state in this case? Yeah, very good. Right. Your answer is right. So if I want a DFA that accept all binary string that end with 0, 1, it means I want minimum 0, 1, right? That is my state number 1. And minimum I want it has to be end with 0, 1. Each and every string has to be end with 0, 1. Fine. That is my state number 1 and that is state number 2. And I want DFA, keep in mind. Now, 0, 1. It may be the case that my string may be 0, 1, 0, 1. It may be the case that my string may be 0, 1, 0, 1. All these strings are end with 0, 1. So 0, 1, then again 0 and 1. In this way, it end with 0, 1. And now I just need to convert these things, the thing, all this machine into the DFA. And we know that in DFA, from each and every state, for each and every symbol, we have only exactly one transition. So suppose that at state number one, if one came, I don't bother about one. That means string is like this: 0, 1, 0. It is end with, or if string like with 1, 1, 0, 1. Yes, 1 and 0. Now see, my dear students, at state number 1, we already give the transition of 1 and 0. Now see, in at state number 2, this is my state number 2, this is my state number 3. Now see, at state number 2, I already have a transition of 1, but what about 0? If any 0 came, you have to make it self loop. Why? Because it may be the string that 1001, that is 1, 0, 0 and 1, right? So in this way, it is also the right string which end with 0, 1. So I completed the state number 1 and state number 2. Now see, my dear students, if I talk about state number 3, I already give the transition of 0, but what about the transition of 1? In the case of transition of 1, suppose that I reach with at the state number 3 by reading 0, 1. And if 1 came, then again I want 0, 1. And 0, 1 always start from state number 1. That's why this is the case. So we require 3 state. Answer is 3. Next, what is the minimum number of state required in a DFA that accept all string containing substring 101? Please do it. Do it fast. Okay, dear students. So yes, that is the right force. 4 is the right answer. Very good. So now see, my dear students, we want all such string which contain the substring 101. And here there is a difference between substring and subsequence. Substring always be consecutive in nature. It means we want all such strings which contain 101 in consecutive manner, right? Very good. Now, this is state number 1, state number 2, 3, and 4. After getting 101, it may be anything because already we want that we already achieved. Now we are going to convert these things into the DFA only. Now, can you just tell me at state 1, if 0 came, what happened? Any number of 0 it may be, because ultimately we get 101 in consecutive nature. So state 1 is complete. What about state 2? At state 2, if 1 came, again make a self loop because ultimately we want 101, and that loop 1, then 2 to 3 0, and 3 to 4 1 is considered as a substring. There is a chance if we are taking the loop. Now, state 1 and state 2 are completed. State 3, 1 is already there. What about 0? It means suppose that you reach by reading 10 to the state 3. If 0 came, then what we need to do? We again want 101. Yes or no? That's why we have to go with the state number 1. That is my point, my dear students. And now suppose that at state number 3 we completed, state number 4 is already completed. So this is the DFA which require 4 states. So 4 is the right answer. The number of zeros is even and the number of ones is odd. Very important problem. Do it fast. Okay, so a DFA accept binary string is the number of zeros is even and the number of ones is odd. See, my dear students, in the first question or second question, we discussed about even number of zeros. So in that case, we require 2 state. We discuss odd number of 1. If we talk about odd number of zeros, again 2 state, because in even machine 1 state is for even counting and 1 is for odd counting. Fine. So if I talk about what is the minimum number of states required, so we see it is so whenever you have a machine with the AND, so individually try to make the number of states, and there is one more concept of dead state. We will not discuss about this one. Maybe we will, when if we see the question, then we will discuss. Right now we require 2 into 2 4 states like this: 1, 2, 3, 4. So suppose that this even A and even B, or even 0 and even 1, even 0, odd 1. Fine. Next, odd, even, and odd and odd. So first one talking about the 0, second one is 1. So we require even 0 and odd 1. Even 0 and odd 1 is here. So this is the final state. Now see how we can even. So if I want odd 0, then even 0. Now you can see it's very simple. So in this way, my dear students, I can draw, and which we are having 4 states. So if you make the first state, that EE, as the final, it accept even 0 and even ones. If you make the OE or 0E as then odd 1, odd zeros and even ones. Fine. If you make the final state as 0, 0 or O, then odd 0 and odd even. Fine. That is the case. Now see. The sixth one. What is the minimum number of states required for a DFA accepting binary number whose decimal value is divisible by 5? Whenever there is a case of divisible by 5, keep in mind we require 5 states. But specifically in case of 4, because it's a mod machine, something like that, okay? But in case of 4, you just try it, and in the next class we will discuss, okay? So very simple. So you can see like this, very simple. Here 0, here 1. If I make a transition table, so Q0, you can say Q0, Q1, Q2, Q3, Q4. Again Q0, Q1, Q2, Q3, and Q4. Q0, Q1, Q2, Q3, and Q4. And this is the final states, my dear son. That is the case. Okay. Fine. Let's see. Can you just tell me the third symbol from RHS is 1? We require the minimum number of states. Just tell me what is the total number of states required when the third symbol from RHS is 1. See, my dear students, first let's talk about the second symbol from RHS. Right is 1. From right means right hand side is 1. If I, in general, if I talk about the TOC or nth symbol from RSS. Keep in mind these formulas so that quickly you can solve the questions. If I talk about nth symbol from right hand side is equal, it requires 2 key power n states in DFA. And if I talk about nth symbol from left hand side, it require, keep in mind my dear students, n plus 2 states always. So let's go with, so in our question, the minimum number of states required for DFA from RHS, the third symbol, right? So we require 2 key power 3 equal to 8 state. Fine. And in the case of LHS, it required 5 states. Now see, let's talk about the second symbol from RHS is, so in the case of second symbol from RHS, see, from RHS is 1. So first symbol may be 0, but second symbol may be 1. Yes or no? That is the point. Getting my point? So we have to make 1. Before that, any number of ones. If any number of 1 came, it create a problem. We want second symbol from RHS is 1. It means anything may be here, then either 1 0 or 1 1. Yes or no? We want this type of thing. Second symbol from RHS is 1. Now see, it means here we have 1. After that, it may be 0 or it may be 1. We want both. Now see, before that any 0 came, don't bother about that. Now, now listen carefully. If I want, if here any number of 1 came, don't bother about that. Because in that case, either this one is the second symbol or this one itself is the second symbol from RHS. But if it came to 0, then now this one or this one again is the second symbol from RHS. So state 1 is complete, state 2 is complete, state 4 is complete. Let's talk about state 3. In state 3, if 0 came, then again we have to start from the initial state. But if 1 came, then just start from here. That is the main point, my dear students. Okay. In this way, we require 4 states. Now tell me, what is the minimum number of states required in DFA over to accept all string whose length is congruent to 2 mod 4? It means anyhow remainder is 2. So again, it is a modulo 4 machine. We require 4 state, my dear students. 1, 2, 3, and 4. But this is finally is which one? Which, see, this gives me the remainder as 0. This give me remainder as 1. This give me remainder as 2. And this give me remainder as 3. So I want 2. So this is the final state. Whose length? It means 0, 1. We are talking about only length. 0, 1. Again 0, 1. And again 0, 1. Getting my point? Yes. Tell me the right answer of this one. Do it fast. Does not contain substring. DFA accept all strings that do not contain 1 1. So you can do one thing. First, make a machine which contains substring as 1 1. Yes, this contain the substring as 1 1 because in substring we want consecutive 1 1. Now we want to convert it into which do not, it means we do not want 1 1 as a substring, all the remaining strings. So just make all the non-final as final and final as non-final. So previously state 1, state 2, state 3 is my final. Now make state 3 as non-final and state 1 and 2 as final. So this is the right answer. Number of states is still same. Tell me the right answer. Number of 1 is divisible by 3 and number of divisible by 2. See, again, whenever you have a mode machine, number of 1 is divisible by 3, required 3 states. Number of 0 divisible by 2, required 2 states. So total required 3 into 2 because no one contains the trap state or dead state. So 6. 6 is the right answer. Do it fast, do it fast. Just construct the machine, do it fast. So this is the case. Fine. Right. Let's go with some questions related to the grammar. Which of the following is a valid right linear grammar? Very important problem. Right linear grammar. That means we are talking about regular grammar. Can you tell me what is the format or syntax of regular grammar? And then in the regular grammar, we have one format that is called right linear regular grammar. Tell me which syntax is the right one. Yes. See, we have, first of all, we have two type of grammar. So in regular grammar is of two type. The first one is right linear grammar and left linear grammar. Right. So what is right linear grammar? What is the syntax? In the right linear grammar, in each and every production, variable has to be come in the right side, either no variable came. In the case of left linear grammar, variable always be the part of in the left side of each production and single variable in right linear as well as in left linear. Fine. Now we talk about, see, above one is the right linear grammar, below is the left linear grammar. Right. Now see, S goes to AA. Now, in this first production, S goes to AA. Variable is at right hand side. Variable is a right hand side and no variable. That is a right linear grammar. Let's talk about B. In B, in the first production, S goes to AB. We have two variable, which is not allowed. Only at most one variable is allowed. In C, variable is at the middle, not allowed. Again, not allowed. Please solve this one. In a right linear grammar, products are generally in the form of, see, here we have variable at the right hand side or no variable. This is right. Variable left hand side or this one. Again, this is right. This is wrong and this is wrong. That's the point. Next. Consider the which of the following language is generated by the grammar. Very important. Very important. Now tell me the right answer. See, my dear students, if I talk about the grammar, from this grammar, what we are going to accept. Let's let's talk about this production. A goes to B, A or epsilon. So it accept B star, right? Now let's talk about this production. It call B and then A and A generate B star. Let's talk about this one. This one AS. Ultimately, it has to go with the B. It means A star. So A star B star. A star B star. B is the right answer, my dear students. B is the right. Next. Which of the following grammar is not regular? Very good. Not regular. Tell me. Yes. Now see. Which of the following grammar is not regular? And we know what is regular grammar. It is of two type, either right linear or the left linear. Fine. That is the main point. Now you just need to check the syntax. Fine. The syntax. Which one is the follow the right linear grammar or the left linear grammar, my dear students? So if I talk about the first one, variable is at the right hand side. Variable at the right hand side, right hand side. This is right linear grammar. Next, left side. Variable is at left, no variable. This is left linear grammar. Next, ASB. Even this is not the right linear or never not the left linear. That's why not good. Not regular grammar. And this one is right linear grammar again. So these three are the right one. Next, the last one. Consider the grammar. Which of the following string is generated by the grammar? See, again the same. It generate what? It generate 0*1, and this one generate 0*, then it equal to 1a, then 1 and a equal to 0*1. Now 0, 0, 1, 0, 1, 0, 0, 1, 0, 1. That's fine. 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1. That is also true. 0, 0, 0, 1, 1, 0, 0, 0, 1, then 1. That is also true. In 1, 1, 0, 1, 1, 0, not possible. That's why it is. So which of the following string cannot be? Question has to be cannot be generated by the graph. Fine. So these are the 15 questions we discussed in our first lecture. Tomorrow also we are going to move on the push down automata and some of the closure property, then regular expression of the this regular language and finite automata. Thank you.